Inductor, together with resistor and capacitor, is a basic component appearing in the majority of electrical system in use today. An inductor is actually a coin-generating magnetic field to store energy when the current is passing through it. Let's look at an example to see how the inductor behaves in a DC circuit. Given a circuit with the applied voltage E, containing two resistors R1 and R2, and an inductor L. Let's find out how the current and the voltage across the inductor change over time when the switch is closed and when it is opened after the inductor reaches the steady state. First thing we need to do is using the Thevenin circuit to determine the total resistance by short circuit the voltage source. It can be seen that the current won't be going through R2, which makes the total resistance when closing the switch equal the value of R1. At the instant the switch is closed, the inductor acts as an open circuit, preventing the current going through it. The absence of the current going through the coil and the circuit results in 0 volts across the resistor as determined by using Ohm's law. Now, we can calculate the voltage across the coil by applying Kirchhoff's law around closed loop, which will be equal E volts. After the time t equals 0, the current increases very rapidly and then at a much slower rate as it approaches its steady rate value Im, which is equal to the source voltage divided by the total resistance. The time for the inductor to reach its steady state is considered as 5 time constants. That is also the same time period for the voltage across the inductor to drop to 0 volt. After the steady state, the switch is opened. Because the inductor is fully charged, at the instant the switch is opened, the current IL still maintains the same direction and magnitude, which is equal to Im. The voltage across the inductor reverses polarity and equal negative Vm, which is determined from Im and total resistance by using Ohm's law. Note that the total resistance now is equal to the sum of R1 and R2. After the switch is opened, due to the absence of a closed path, the current drops from Im to 0, releasing the energy stored in the form of a magnetic field. It also causes the voltage across the inductor, with the reversed polarity, decays from Vm to 0. It takes 5 time constants for current and voltage to completely decay. Notice that the new time constant now is defined using the inductance and the new total resistance, which is equal L over the sum of R1 and R2.